As World War II ended with the atomic bombing of Japan, a secret war commenced, ushering in one of the most terrifying periods in recent history. Scientists in the Soviet Union and America set to work designing even bigger bombs. Culminating 50 years ago in the biggest man-made explosion of all time, a single bomb which could wipe out millions of people. The awesome power of these devices still casts a shadow. In the Pacific, whole islands were vaporized or turned into a radioactive danger zone. And the scientists themselves were often flying blind, pushing the science too far in the effort to stay ahead.
One scientist panicked and was crawling up the beach in terror as this thing kept going up and up.
Now we'll learn what really happened in this clandestine war. From one of the leading scientists.
The cloud just kept rising and rising, but what frightened me was the heat. I never thought the heat was going to turn off.
From a U.S. Marine who barely escaped with his life.
I turned around to my buddy and I said, "Hey, I think we're going." He said, "Yeah, I think you're right."
These explosions changed the course of the Cold War, shaping the world we live in today. Half a century on, we'll uncover the story of this secret struggle. The race to build the world's biggest bomb.
Look at that. It's all consistent across the board.
What's the interval on that? Okay, we're going to have to pin down location on this.
In October 1961, technicians at a U.S. military monitoring station close to Washington, D.C. received startling news. A shockwave on their seismograph appeared to come from a place far from any earthquake zone. From Russian territory inside the Arctic Circle. There was only one possible explanation for what looked like a mini earthquake. The Soviets had a bomb many times bigger than anything the US had built. One of America's key scientists at that time remembers when the news came through.
We were impressed. That meant they had a deliverable 50 megaton weapon. That was pretty scary.
A weapon more than 3,000 times bigger than the Hiroshima bomb. Agnew knew exactly what that meant because he was there right at the beginning. As a brilliant young physicist, he worked on America's wartime Manhattan Project. Agnew flew on the historic mission to Hiroshima. In a B-29, shadowing the delivery aircraft, Enola Gay. His task was to measure the yield from this first atomic bomb.
When the bomb went off, we saw the light, then we felt two shock waves, which surprised us, and then we realized one of them was a reflection from the ground. And then we dashed over to look out this little porthole, and I took the pictures of the Hiroshima cloud.
His film is a unique record. The only moving images of the Hiroshima bomb. Agnew flew back to help prepare the next bomb. He's pictured here, carrying the bomb core itself. When dropped on Nagasaki days later, this small, innocuous-looking device effectively ended World War II. bombs had killed more than 150,000 people. Many more would perish from their injuries and the effects of radiation. When he learned of their power, Soviet leader Joseph Stalin decided he too must have such a weapon. The Cold War arms race was underway. 2 weeks after Hiroshima, Stalin ordered scientists here at Moscow's Lebedev Institute to deliver him an atom bomb. Physicist Boris Altshuler was part of an elite community of Soviet scientists. His father helped design Stalin's first bombs.
My father really understood that they must have the bomb, because it's necessary to save our country, to save peace as they believed it.
He was brought up in an Atomgrad, a secret township of scientists 400 kilometers east of Moscow.
I lived there, and I can tell you, they worked absolutely night and day to restore the balance.
We physicists and chemists said it would be just a matter of time. In fact, the politicians thought it would take them longer than we thought it would take them.
Agnew and his fellow scientists were tasked to develop ever bigger bombs to ensure the United States stayed ahead of the Soviets. But testing these weapons would turn an island paradise into a raging inferno. As America and the Soviet Union raced to develop ever more powerful nuclear bombs, a series of vast experiments would be conducted here on Bikini Atoll, one of the most remote and for many years most secret places on Earth. This coral atoll in the Marshall Islands lies 4,300 kilometers southwest of Hawaii. In 1946, the US decided this is where it would test the next generation of weapons. Historian Richard Rhodes is a leading chronicler of the period, a Pulitzer Prize winner. He says the atom bomb spelled excitement and even sex appeal.
The bikini was invented by a French designer in 1946. They decided to name it after the sexiest place at that time on the planet, which was where the United States was conducting nuclear weapons tests. The bomb at that time had a kind of charisma that, of course, it soon lost.
The bombs were big news, and the people of Bikini seemed happy to be center stage, even if it meant temporary upheaval.
These first pictures of the little island show the 165 men, women, and children as they prepare for the move to another small island, a safe distance away.
The first test, in 1946, would be one of the most remarkable experiments ever conducted. The Americans assembled millions of dollars worth of weapons and a fleet of 95 deserted warships. Captured Japanese and German ships, plus old American vessels, were lined up as targets, with further data from animal subjects.
Different animals have been placed aboard the ships. Some were shaved in order that the effects of heat and radiation on their skins could be observed. 5, 4, 3, 2, 1, fire.
ships and weapons were sacrificed, it sent out the clearest signal. The rules of war had been rewritten. The atom bomb trumped yesterday's weaponry. And only America knew the secret of how to build one. Or so they believed.
Years before our experts believed it would be possible, Soviets in August 1949 tested their first atomic bomb. And there was panic in Washington as a result.
The Soviet weapon was an almost exact copy of the Nagasaki bomb. So could there be a spy inside America's super-secret design center in New Mexico, Los Alamos?
There were American idealistic physicists who gave American secrets to Soviet intelligence. They had ideas that there must be balance. That's very dangerous if only capitalist, imperialist authorities of the United States will have these weapons.
Two spies were arrested, and their treachery kicked this race into an even higher gear.
There was a great rush in Washington to find something that could reassert the balance. And for some of the people in Washington, in fact those who prevailed, the hydrogen bomb was that thing.
The bombs exploded so far at Bikini were all variations on the original atom bomb design. But the force unleashed by a hydrogen bomb would soon make those devices look primitive. There would be two key components: an atom bomb and a tank of hydrogen isotopes such as tritium and deuterium. The primary explosion would force together or fuse the bomb fuel, producing immense heat. A thermonuclear reaction, releasing energy measured in megatons, millions of tons of TNT.
The other important thing about a hydrogen reaction is that it's kind of like a fire. The more fuel you add, the bigger the fire. It has an unlimited potential size, whereas the biggest fission weapon we ever built was 0.5 megaton, 500,000 tons of TNT equivalent. You really couldn't get any bigger than that.
We all agreed, at least the technical people, it would just be a matter of a few years before the Russians would have the same capability.
The fact that the Soviet Union had so quickly, with the help of espionage, developed their first atomic bombs made it certain from the point of view of the United States Joint Chiefs of Staff that yes, we must have this weapon.
But would it work? It was down to Harold Agnew, now in his early 30s, and his Los Alamos colleagues to build the world's first thermonuclear device. Codename Mike.
I was the project engineer with a small group. We actually put tritium in Mike. We were in charge of doing that. We got the thing fabricated, got it shipped out.
It was an atomic bomb and a long cylindrical tank of liquid hydrogen, surrounded by a cylinder that would funnel the huge burst of radiation that comes off an atomic bomb and turn the material around the hydrogen cylinder into an intense plasma, a very, very hot gas, which would then set off the hydrogen that was in the tank. That was the Mike device.
By November 1952, Mike was ready for testing.
Minus 15 seconds.
I was on the Curtis, which was a seaplane tender, 30 miles away, waiting for Mike to be detonated. frightened me was the heat. We were just in a pair of shorts. And it's got hotter and hotter and hotter. This cloud was 30 miles away, but it felt as if it was on top of us.
Here was a truly historic scientific milestone, the world's first man-made thermonuclear reaction. But at 82 tons weight, what use was it?
Propaganda wrote the first hydrogen bomb was tested by United States in 1952. It's called Mike. It was not a bomb. It was construction like a big three-story house.
It was a bomb that you'd have to, as Robert Oppenheimer said, deliver by ox cart or by ship. Well, that wasn't very useful. You wanted one you could deliver by air.
The race was now to develop a thermonuclear device which would fit inside an aircraft. And despite their early lead, America seemed to be falling behind.
The threat of hydrogen bomb warfare is the greatest danger.
In 1953, the Soviets announced they'd developed the first practical H-bomb. Could the US do the same? Six months later, Los Alamos produced their answer to the Soviet bomb. Far more compact and based on the lightest metal that there is, lithium.
There are various versions of lithium, isotopes they're called. And the one that was needed for this weapon was lithium-6. It had 3 protons, 3 neutrons, lithium-6.
The fuel mixture, known as lithium deuteride, was packed inside this aluminium cylinder. Bikini was about to witness the most powerful explosion ever staged by the United States, codenamed Castle Bravo. But this time, things would go dramatically out of control.
They tested the bomb with liquid hydrogen, but they never tested one with lithium deuteride. And the measurements had been made wrong, as it turned out.
The scientists' miscalculation would have terrifying consequences. For some of their own team, for hundreds of Pacific Islanders, and for unsuspecting fishermen in the path of this massive explosion. Almost 60 years ago, John R. Haldeman was a young Marine corporal. Shipped out to the Pacific for this top-secret mission, he stood guard over America's superbomb.
It looked like a big propane tank, about 5 feet in diameter, 20 feet long. I wrote my name on it, being smart. Signed it. But we had to stay with that until it was all set up to go off. And you weren't allowed on there. If your name wasn't on the access list, you had orders to shoot to kill.
Bikini Atoll is a ring of small islands. Haldeman stood guard in the northwest corner, where Bravo would actually detonate. But it would be triggered from the island of Enu, 35 kilometers away. What happened next was documented in this once classified film.
Starting at H-48 hours, all personnel at Bikini Atoll were evacuated. The only men to remain were the members of the firing party, protected in their bunker on Enu Island.
The bunker is located just beside the island's landing strip. It meant that if things went wrong, they could call in a helicopter for rescue. But the men inside here felt safe. Protected not just by reinforced concrete, but massive blast doors. Their job was to ensure that all monitoring devices were running, and finally, prime the firing circuit itself. If the scientists' calculations were correct, the lithium deuteride mixture would erupt with the force of 5 million tons of TNT. If it went much higher, the 35-kilometer margin of safety might not be enough. Their bunker was even made watertight, in case Bravo unleashed a tidal wave. As 0 hour approached, Marine John Haldeman was aboard the USS Curtis, the ship carrying top brass and scientists, as it had been for Operation Mike.
We were 23 miles from ground zero, and they're starting the countdown. And they got down to 10 seconds, and you get kind of goose pimples, and your hair stands up on the back of you. We had dark goggles on, but when it went off, you could see the bone in your arm, like looking at an x-ray. When we did turn around and take our goggles off, we all thought it'd be off in the distance. It was right on top. And you could see the shockwave coming, like a miniature tidal wave or tsunami. You're grabbing hold of lifelines and hanging on the gun mounts, and guys are sliding across the deck, and you're grabbing them. And then it tilted back the other way, and I turned around to my buddy, and I said, "Hey, I think we're behind." He said, "Yeah, I think you're right."
The scientists left behind on Bikini were even closer than Haldeman's ship. How could they survive this rogue super bomb? On March the 1st, 1954, on Bikini Atoll in the Pacific, America's most powerful hydrogen bomb test had gone out of control.
It was a terrifying moment. The explosion reached out so close to the blockhouses that they barely got out alive.
The leader of the firing party, Dr. John C. Clark, later recounted his experience. At 0 plus 20 seconds, a shock, like a giant earthquake. At 0 plus 90 seconds, the air blast. So powerful that the concrete walls creaked. But it was their Geiger counters measuring radiation that spelled potential disaster. Bravo had created a vast plume of radioactive fallout, far bigger than expected and heading in a direction no one had predicted.
Fallout in a nuclear weapon is more a product of the material that's churned up by the explosion than it is of the explosion itself. The explosion is so hot that it just basically turns everything in the bomb into a gas. A bomb that's exploded on the ground stirs up the earth and irradiates the elements in those materials. And then that material is intensely radioactive. And its radioactivity is what typically we call fallout.
At the bunker, radiation levels were heading towards a lethal level. Clark knew that a helicopter would soon be on the way, but the men still had to get to the landing pad. The helicopter blades would kick up fallout which had already settled, increasing the danger still further, since the men hadn't been issued with protective clothing.
Get that one, this one, on the bottom.
And so they devised a primitive solution. These men, who just set off the most potent weapon at that time in history, would shield themselves from its deadly effects with bed sheets as they hurried towards the waiting chopper. The USS Curtis, 37 kilometers from Ground Zero, was now also in harm's way.
We were the closest ship to the blast. And that radioactive dust, it's like snow. They just ordered us below deck, and we went below deck and buttoned up. They came around with Geiger counters, and the Geiger counter would sing when they bring it around your body. I must have been down there 10 days. It stunk down there. It got really right. And if anybody went out in the hatches, he had orders to shoot.
So what had gone wrong? Although the principle of the hydrogen bomb had been proved with Operation Mike, each new weapon was pushing science to the limits. Dr. Martin Kalinowski, a nuclear physicist at the University of Hamburg, was asked to examine the declassified data from Castle Bravo.
At that time, much of the nuclear testing was trial and error. The test was their experiment to find out new information. And one particular information that is very important for nuclear physicists or bomb physicists are the so-called cross-sections, the capabilities of nuclear materials to react. Lithium consists of two different kinds of nuclei, lithium-6 and what is called lithium-7. 7 indicates that there is one more neutron in the nucleus. Physicists at that time thought that lithium-7 is kind of inert, it doesn't contribute in any way to the nuclear explosion.
You have to realize this, we were pretty ignorant in those days about cross-sections, and this wasn't thought of at all. We were ignorant of the fact, but we should not have been ignorant.
I looked at the cross-sections for lithium-6 and lithium-7, and the comparison reveals lithium-7 does have a high cross-section. That means a high probability of undergoing a nuclear reaction.
This particular fuel in this bomb was 30% lithium-6, 70% lithium-7. What the scientists were not aware of was that lithium-7 would be stripped of one of its neutrons early in this reaction as it blew and turn into lithium-6. At which point it would become bomb fuel. The weapon was designed to have a yield of 5 megatons. But because of this unknown reaction in lithium-7, it had a yield of 15 million tons of TNT equivalent.
The power unleashed by Bravo is still evident today. 3 small islands at Ground Zero were simply vaporized, leaving a crater more than 1 kilometer wide and 60 meters deep. And there were terrible human consequences too. This fishing boat, named Lucky Dragon, preserved in a Tokyo museum, bears witness to the killing power of the bomb. As dawn rose, the ship, with a crew of 23, was sailing 132 kilometers east of Bikini. This white powder, like snow, began to fall from the sky. It was like a blizzard of fine snowflakes. But I thought, this is the Pacific. How can it be snowing? It fell on my head and face, and I licked some. It didn't melt like snow would have done. It was like eating sand. Within days, the crew was suffering from acute radiation sickness. They hurried back to port in Japan, but despite doctors' efforts, the radio operator died. Others took a long time to recover.
There was a huge outcry in Japan. I mean, this was the one country that had already been atomic bombed, the only country in the world. For now, some of its ordinary fishermen to come home sick with radiation poisoning produced a national outcry.
The remoteness of Bikini Atoll should have prevented such contamination. We asked Dr. Kalinowski whether contemporary records can provide any explanation.
I looked at the weather data, and I think that is one of the main reasons why the fallout was higher than expected. We're looking here at the meteorological situation of the Castle Bravo test. Ground zero is marked here with this black star. The lines indicating so-called trajectories. So these are the paths that particles would follow within 24 hours after the explosion. The red line indicates a particle 10 kilometers height, whereas the green line is for a particle almost at ground level. The striking fact is that the green line goes into exactly opposite direction of the red line. The winds are blowing into different directions. At high altitudes, the winds are blowing towards the east, and at low altitudes, towards the west.
The Bravo commander expected fallout to blow towards empty ocean. Instead, most of the radiation was carried eastwards high into the air to descend on the USS Curtis, the Lucky Dragon, and nearby islands.
The major fraction of radioactivity is transported in high altitudes because the mushroom cloud lifts the radioactivity. I'm not sure whether they missed the information about the wind fields, but their impact on the fallout was probably underestimated.
The radioactive plume caused widespread contamination. On the islands to the east of Bikini, 260 people were quickly evacuated by the US military, but many showed clear symptoms of radiation exposure.
Usually before shots they were very meticulous in predicting what the wind was going to do, but of course winds can change very quickly. Just unfortunate.
There began in this incident a change in the view that the world had of these tests, and to some degree also of these bombs.
Bravo was 1,000 times more powerful than the Hiroshima bomb. But as relations between the superpowers reached a critical stage, scientists perfected a weapon of even greater magnitude. In Germany, in 1961, The flashpoint was over who should control Berlin. Soviet leader Nikita Khrushchev faced off against John F. Kennedy.
Khrushchev decided to do something about it and built the Berlin Wall, which came remarkably close to starting a war. Khrushchev called in his scientists and said, let's show the Americans what we can do.
What Khrushchev wanted was a 100 megaton bomb, the biggest of all time.
It was a deliberate threat. He said, let's build a really big one and show them what we can do.
The scientist Khrushchev summoned was Andrei Sakharov, the brains behind the Soviet bomb program for the last decade. Boris Altshuler studied under Sakharov and was a close friend for 20 years.
He didn't consider it as some tool to kill anybody. It just was a tool to defend us, our country, from being killed.
Sakharov had 3 months to produce the biggest explosive device of all time, dubbed the Tsar Bomb, or King of Bombs. It had to be small enough to fit in a plane, yet still produce a force 6 times bigger than America's Castle Bravo. This would be a 3-stage weapon, rather than the 2 stages of the American bomb. An atom bomb would be the fission detonator, compressing the bomb fuel in first one thermonuclear reaction, but then another.
The scientists once thought about making a bomb that would be 1,000 megatons. And that would be a perhaps 4 or 5 stage weapon to get that much yield. It wouldn't be useful because once you get above 100 megatons, the fireball is the thickness of the atmosphere of the Earth, 10 miles. And any further blast is just going to go out into space. It's not going to do any good.
Sakharov was working under orders. But as the bomb neared completion, he insisted on one vital change. To limit the potential fallout, Sakharov amended the design to 50 megatons. Still, the most powerful object mankind has ever made was now ready to explode. The most powerful bomb ever produced, the Soviets' Tsar Bomb, would detonate over the remote Arctic island of Novaya Zemlya. Mini wilderness, the snowbound territory, was far from centers of population to be affected by the bomb's fallout. As dawn broke, the crew assigned to carry out this historic mission were given their final briefing. Mission Control was a military airbase in northern Russia, 900 kilometers from the drop zone. The crew had been hand-picked, and their aircraft had to be specially adapted. The Tsar Bomb, weighing 27 tons, had been fitted with a parachute and would be dropped from an altitude of 10.5 kilometers. The bomb would fall for 6,500 meters before detonating. Enough time, it was hoped, for the aircrew to escape the devastating explosion.
There were real concerns. Sakharov said now they do something which was never earlier happened on the history and on the earth. To foresee exactly what will happen, shock wave came to the airplane. An airplane fell down about a kilometer. But it was very high, so they did perish, but it was almost broken.
The most powerful man-made explosion in history produced a mushroom cloud which peaked at 64 kilometers, around 7 times the height of Mount Everest. Buildings 100 kilometers away were destroyed. Windows were shattered 500 kilometers away. Monitors who picked up the shock wave had been expecting something momentous, but nothing of this magnitude.
We were really impressed the fact that they were able to airdrop that thing. And even more impressed when we realized that had they used much more uranium in it, which they could have, it would have been 100 megatons. It was really amazing.
The implications were clear to the analysts. If the Tsar bomb had dropped on Washington, D.C. and detonated at an optimum height of 600 meters, the initial fireball would incinerate everything and everybody within 5,600 meters. People 20 kilometers away would suffer third-degree burns. Most buildings 30 kilometers away would be destroyed, releasing more than 3,000 times the energy of the Hiroshima bomb. It would kill over 1 million people instantly, perhaps 3.5 million in total. The altitude at which a bomb detonates is a critical factor. Dr. Martin Kalinowski was asked to determine what happened to the fallout from the Tsar bomb.
The big difference is that the Tsar bomb was exploded at 4 kilometers height, whereas the Bravo test took place close to ground. But there is a second issue about wind speeds and directions. This is a snapshot of the plume after 6 hours. Ground zero is marked here with the red star. Different colors are indicating the part of the plume at different heights. The important thing is there is no vertical transport, neither downwards nor upwards. The whole plume is traveling towards the east. Particles transported with fast wind speeds had no chance to reach ground. It took 48 hours before any fallout reached the ground. By that time, the very short-lived radioactivity had already decayed, and the concentrations were very low.
The low initial fallout of the Tsar bomb was still too much for the man who built it. Sakharov's own estimate was that 500,000 people worldwide would suffer in succeeding decades as the radiation deposited by the huge cloud slowly decayed. In a remarkable turnaround, Andrei Sakharov became a fierce critic of nuclear testing, until both sides agreed in 1963 to a treaty confining further tests underground to prevent fallout. The race for a superbomb was ended, and Sakharov was ultimately awarded the Nobel Peace Prize in 1975. But the legacy of this deadly contest is still evident on Bikini, which remains too radioactive for people to live there long term. Today, Bikini Islanders live elsewhere in the Marshall Islands, and some of them in the United States. Leaders of the exiled community, including the mayor, make periodic visits. This one, the first in 2 years.
Right now we are at the old graveyard site from before the testing was happening on Bikini. Bikini are all one family, so anybody dies, we all related.
The The United States has, over the years, paid almost $200 million in compensation and in its attempts to clean up Bikini. But it looks like remaining an island of ghosts.
The children of Israel, they traveled for 40 years. But children of Bikini, I really don't know if we will ever come back to Bikini.
The bombs laid waste one tiny island and helped shape history for the rest of the world. Does the man who played a key role from Hiroshima onwards have any regrets?
I never had any qualms that what we were doing was necessary at the time. But I've said many times politicians should have to get in their underwear and watch a megaton blast and feel the heat and really make better thinkers out of some of them.
Explore one of British history's biggest mysteries in Ghosts of the Mary Rose, brand new tomorrow at 9. Next tonight, it's the premiere of The King's Speech Revealed.